We're exploring sorting out, and Kieran's got this activity that he runs with his middle school classes in particular. And it just merges together curriculum, behaviour management, all the different aspects of what it is to be a good classroom manager. Kieran does it really well, and so it's going to share his practice using school. So Kieran, take it away.
Alright, like Laura said, this is the first thing I run with most of my classes in the middle school, sometimes in Year 10. Boggle's a spelling game. It's also, you can get it as an actual physical game, but I just make it using PowerPoint. Basic words of it are that you can't have anything less than 3 letters as a word. The maximum is 16 because that's what space you've got. No proper nouns or slang. There's room to move on that, I guess, if you want. The letters must touch each other in order. They can go in any direction, but you will see in a second, each square must touch the next square of the letter in that word, and you can't go back on a letter. I usually give kids 3 minutes to complete it. Probably 90% of my class is completely involved as they start, so I usually have total silence once it starts going. The few who protest, I go around and I've got that time to have little conversations with them about it, or to give them another little task while we sort of, everybody else is working on it. Also, the other side of it is when I do tell them to tally up, that gives me time to mark the roll. So I then also have the first sort of 5 minutes of the lesson, they're quiet, they're completely engaged, and yeah, they're sort of mine. So this is what Boggle looks like. It's really easy to do. Put together on a PowerPoint, you insert the table 4x4. Often I'll put in a particularly long word that I'm after, sort of halfway through I'll say there's a word that has this many letters. These are the things that are linked to it. I might say it means something similar to this, or it relates to what we've been looking at in the classroom, or somehow it links to the day, or sometimes there'll be a message in there or something like that. You've got to be very careful to proofread and double check and make sure there's nothing inappropriate in there, because that's slipped through quite a few times. So with this one, there we go. A couple of things. I encourage students to look for combos of letters. So when you get these ones together, those 4 letters give you T, eat, ate, seat. So you get points straight out of that. If you get S-T-A-R next to each other, and they all touch in that little bit, you get rat. Rats, art, arts, tar, and tars. The longer word in this one, can anyone see a 9-letter word? Remember, each letter needs to be touching, so for example, T touches the E, touches the A. I couldn't have, what couldn't I have? M-I-S-T, because the S doesn't touch the T, and then the E, and then the R. They don't touch each other, even though the letters are there to make the word.
So diagonal for that?
Diagonal's fine as long as they touch. You can go forwards, backwards, any direction, as long as they touch. If they're stuck, I might say something like it starts in a corner. Criticism is the longest one. Criticism. So, it's not all about finding the longest word, even though plenty of students, that's the only thing they're focused on. You can also win it just based on points, and sometimes they'll put plurals in there, so there's heaps and heaps of 5 letters and stuff like that. I'll talk to you about the way we score it in a moment, but we might play it on a different one. That's alright, so this will take 3 minutes. Alright, often when I set my class up, before I have my Boggle sitting there, I'll have a photo. And where I can, the photo is just meant to be something that they all, gets their attention. This one actually relates to Shakespeare. So I can tell them that interesting little story about how that guy's dying wish was that he'd be on stage in Hamlet, and he got his dying wish with Doctor Who. Alright, so if you guys were in my Year 8 or Year 9 class, I've been telling you we're about to start with Boggle. You've got 3 minutes, and your time starts now. You're looking for words and you're writing them down. That's all you're doing. You can use iPads or you can just brain list them. There is nude. Thank you, Cliff. might cut you guys short by a minute, so you're halfway now. There is I think it's 14 letters. And if I said, it's been a long term, again, you look for combos as well. You've got 30 seconds left.
No, it's not enough. Understatement.
Game of silence. 20 seconds left. And if you hadn't picked it up, several people have shouted it out. It starts in the corner. Might be a clue that I give you as well. You got 5 seconds left. How many words? And you tally it up. I told you before. Alright, now to tally in Boggle, it's quite simple. With the exception of 3-letter words, which are worth 1 point, however many letters the word has, you take 3 and it gives you the point value. So a 10-letter word is worth 7 points. A 9, 6, and so on and so forth. The highest scoring word would be a 16-letter word, and I do them from time to time. The only exception to that rule, a 3-letter word is still worth 1 point.
So there's a 4-letter word worth 1 point?
And I already said that. And I've started making lists of when students ask me questions that I've already answered.
Why is a 4-letter word worth the same as a 3-letter?
Because it is.
It's not fair.
It's not fair.
You've learned something today. So, after people are tallied up, I might say who's got between 1 and 10. You've got between 1 and 10. Read.
I agree.
11 and 20. Alright, I'll give you another 30 seconds.
Sue doesn't. 11 and 20, we did that one already. 21 30. You did not. You can't get up to 2. 5 and 30. What did you get? 34. What was your longest word? Understatement, which of course was the longest word there. So, Peter would win the prize in that one. And that's the first 4 to 5 minutes of the lesson. Kids are quiet. They're engaged in spelling. They're engaged in potentially the ideas of the lesson. I've marked the roll, maths. Yeah, sometimes there's riddle-esque qualities to some of the things. And yeah, that's how I start my lessons. And when I teach kids from past years, the most common request is as soon as I walk in the room, can we play Boggle? So yeah, maybe it's just because they know they get a reward. Yeah.
Do you have any way of choosing letters each time you do one?
Well, sometimes I Google 16-letter words and put them all in there. Sometimes I'll just think what's a long word I could consider that links to what we've been doing. Again, you've got to be really careful about where letters sit. I've learned that, yeah, that's happened quite a few times. And for some of the lower level kids, if they're saying I can't see any, you just remind them things like think about our combos that are always there, and they just start to get the picture. No, that doesn't work, does it? And eat. Yeah, plus it's done. So that's Boggle.
Thanks, Kieran. Thank you, Kieran. So, I just want to ask Kieran as well to do that because in our self-study evaluation, a lot of us came unstuck at the point where we spoke about how all teachers are responsible for the language development of each child in our classroom. And I had a few people say, but I teach maths. How can I possibly teach language as well? And a part of that as language teachers is as simple as vocabulary. So a way that we can help our students develop as language learners outside of language acquisition and language literature is this simple activity as a classroom management tool and also as a way that we are all language teachers across the school. So really simple little tools to help us there. So thank you, Kieran. So today we're looking at sorting out, and we have Jonthan and Amanda, our panel members this morning or this afternoon. We've gone through tuning in and finding out, and today we'll look at that sorting out section. So in our lessons, our units, we've actually tuned our kids and we've given them the reason of why we're learning. They know the concepts, they know the global context, and we can build upon that prior knowledge. Then in finding out, we've gone to that sort of nitty-gritty. The kids are put on their hats as researchers. They've begun to be really involved in that process of developing that factual knowledge, that conceptual knowledge, and beginning to be involved in that debatable knowledge as well. We come to sorting out as where students begin to actually apply their knowledge. This is where we often let go as teachers and allow them to have some scope and to use what they've learned in tuning in and finding out, and to begin to apply within sorting out. So they can begin to sort out, organise, analyse and represent data, look for patterns and make meaning. They can use their preferred ways of learning, which is always a good tip for especially in middle school. They can identify gaps in their own learning. They can express the new understandings and clarify connections, so both disciplinary and across subjects as well. And the Bloom's terms that help us plan for sorting out is that build, execute, develop, construct. It's all very much about the students being involved and applying their knowledge. That's where we sort of come back to that aspect there. So, Jonthan's going to kick us off today. He's going to come front. So sorting out is really about students having ownership of what we're actually inquiring into. And part of that aspect is helping students think through how they're learning. So Jonthan today is going to go through and just share some of his best practice with how he uses some of the Harvard Project Zero visible thinking strategies in his classroom. So Jonthan, do you want this?
I'll put this there.
Yeah, that's fine.
What's that later?
That's the next one. Yeah, all right. Thanks.
Okay. So what I want to do is the MIP Unit Inquiry Guide has probably for sorting out about 20 different learning strategy tips at the end, which are really handy. I've used a few of those. This is another one. Because it's another favourite. We all have all favourites. And this is called the explanation game. So I use this at various phases. So it's going to be right at the beginning of the unit and just sort of tuning in to raise questions that might be tackled, that might become relevant. This example is looking at, in sorting out, trying to get a little snapshot of how the students are looking at so it's a new stimulus, a new thing, and whether they're bringing understanding or demonstrating understanding that's come from what we've just been going through. You can see connections. It's really about connections, I suppose. So the explanation is just two simple questions. Now I'm using an image. This is, I don't know if it's Ben or Sarah, there's a bunch of images that were available with some really good reflection questions. And so I didn't use those reflection questions for this, I just used one image because I thought it was a really good image for just land, but that's great. And I get the students to look at it. This is Year 8 Christian Studies. The context is we've been looking at big history, themes in the Bible, and really we're kind of looking at a marred world and waiting that's anticipating Christ's coming. And so it's the Old Testament journey of God and his people and all the ups and downs and all the stuff. And I showed them this and I asked them just to notice things, just to look at it for a while. So I'm going to just take you through it. I won't get you to call out, I'll just report what the students have told me. And that's the key. They see things, we go through the exercise, and what they verbalise or write down makes their thinking a bit more visible, which helps me understand where they're at. That's what it's about. And also they can share ideas and learn from each other. So just feast your eyes on that. Seeing this just for a few minutes and wait. Part of this is slowing down the kids to look deeply at something. So the first question is I'm just asking them to notice something, and I might start them off and I'll get them to notice and have a few goes, notice a few things, and I just don't do any follow-up at that stage. And then the next is, why is it that way? So if you've noticed something, can you tell me why is that way? And then the students hopefully will start to volunteer their explanation. That's the explanation game. So, example, a student will notice that these guys they're all fairly well dressed. They're not poor. And you say, yeah, well, they're well dressed. So, why do you say that? Why is it that way? That's the follow-up question. Why do you say that? Well, you see that they're actually not badly dressed. And then something will come out of that. And then maybe we'll go in and someone will just pick out a detail. So in this case, the little child was one of the details I picked up. So often it's the foreground thing, and then it's some little detail. And observations start coming about family connections. I didn't see his dad there. Is his dad in front of it? And then there'll be an explanation now. I think this is from a family that's been broken up. Why is it that way? What's happened? What's in the background? And they've been through that story, the Exodus and a whole lot of things. And so we hopefully start to see some connections there. And then others will start to look in the background. So this is, if you noticed before in the background, they say, well, this was an observation. There's a kind of tent thing they're all passing through, and there's a flag. That's what they noticed. Well, why is it that way? And then other people start chipping in. Well, maybe that's like a border or a crossing, a checkpoint or something. What's going on there? And then we start to get some thinking about the reasoning behind these people moving and what's going on. Is this at the border? And is that a gun that guy's pointing, or is that a camera? Those sorts of things start to come up. Little details. Remember, they're looking at, I don't zoom in like this because I'm showing you zooms and all. And so they're starting to get a picture that there's actually a number of different groups of people. So I noticed that there's some people not on the move. They seem to be military people. There's an army here or something. And so we're talking about, well, what's going on there? And then another observation, the guys in the military don't seem to have very flash conditions either. Like they're in great shape. There's sort of dishevelled tents. Are they living out there? And the explanations come up and we start to explore ideas. So one image then fuels a whole lot of thinking and comments that tease out sort of causal explanations about why something will be the way it is. And then there's also current news of, what is it, the last news is 65 million displaced people is what the latest amount of people in the world. It's like a fourth world of people. So there's all those contemporary issues, the ancient big history issues of the Exodus and so on. And these things hopefully come out. In this case, some of them did. The trick is trying to get a spread across the classroom of people committing, and sometimes writing rather than just discussion is more helpful. The big follow-up is, why do you say that? So why is it that way? What makes you say that is important, isn't it? So that other question that always, I mean, that's one of the best learnings I've had in recent years is to keep asking that question. Anyway, that's a thinking routine. Big plug for thinking routine. That Harvard, there's an online course that you can do which goes through this all thinking. I found it really valuable. It's 10 weeks to your life in the evenings. But it's not expensive, and it's really, I found it really refreshing my thinking about how to do this. There you go.
Thank you, that's brilliant. I'm going to the spotlight just quickly. Much of what sorting out involves is that students are very tactile, they're very hands-on with their learning. And part of that involves failure. So trying something, getting it wrong, then trying it again. There's building that resilience in our students. Jonthan, in your classrooms, how do you harness the power and impact of failure in learning?
Can I switch to design?
Of course you can switch to design, absolutely.
And any class, I think design is one of the profiles, this page is one of the most important profiles, and the idea that you can fail safely is really important. So I think this is something that's encouraged. And the whole idea is they were talking about community practice, so community project. I don't want one idea, I want three ideas. And I'll say, get in the idea, drive it around, test it, if it's not working, pull it over on the side of the road, play get another idea and get into that. So this idea is, test drive, and you're not committed, you don't have to go with it. It's something you can try something that doesn't work, you can shift and change. And trying is really important. So that's kind of the language of it. And the same as design. Get in it, drive it around there. It's not right. It's wrong.
That's right, try again. That's something. So that's brilliant. Thank you. Well, before we go to Amanda, I just wanted to show you as well. I think a few of us have this on our desktops and our desks. I've actually created a whole booklet for you. It's called Developing MYP Unit Planners. It was sent out last year or the year before last, I can't remember. It has a breakdown, like Jonthan said, the 20 different steps. Here they are. It goes through tuning in, sorting out, finding out, sorting out, etc. And it's got different guides for you to use. So please tap into that if you need some help when it comes to planning and looking for ideas and visible thinking strategies. So lastly, we have Amanda looking at how she uses sorting out in her mathematics classroom. So Amanda, I'll plug it in. There we go.
I sort of cross over a bit with the finding out, not necessarily with the tuning in and finding out, but with the finding out and sorting out and going further. It all sort of melds into one. So I found it a little bit difficult to actually sort out sorting out. And anyway, we'll see. Maths is about making sense of the world around us. And the main thing for me with kids to sort out is the fact that it's not magic. It's not a box of tricks or shortcuts that only a few of us understand. And the rest of us are left guessing. And kids will guess until they hope that they get the right answer. And so that's the sorting out that we want to try and get rid of, that sort of sorting out. And we want them to capture the essence of really sorting out what's going on for that particular concept. So we've been through tuning in to get the interest and to get the lens that we're going to focus through. And we've been through finding out to get the discoveries happening, and now we move on to actually sorting out the conceptual stuff that you want them to know. So what I did was to look at the fact that maths is building on conceptual relationships. So years and years ago, I would have pocketed maths into small chapter categories that you teach this, you teach that. Now coming through the MYP and MLATS experience, I would say that you are teaching great big concepts that need to cover much wider depth and variety. And so to get those conceptual happenings is where our sorting out is coming in. So we actually naturally sort out and classify in our everyday life, and what we need to do is bring this into our learning. So the fact that the kids can sort out their learning is then the springboard for the next part of their learning. So it's really important that along the way they find out something, they sort it out, and then that's been a discovery for them, and then that then becomes the platform for the next lot of finding out and sorting out. So in maths we're continually going around that circular planner and going backwards and forwards before you even go a bit further along. So I've put up, I was trying to think of a few examples that ranged from grade 6 through to some of the senior years that would fit into this category. And the first one that I came upon, or came to my thinking, was pi. And if I asked you what a lot of you thought pi was, I'm sure that the answer would be 3.14. And that's probably a really wrong thing to teach children as young people coming through. So pi, as I said there, most people would think of it as being 3.14, and they have no idea of the conceptual understanding that pi is actually a relationship. So it's a relationship between the perimeter, which is the outside or circumference of a circle, and its diameter. So I would have students finding this out using a piece of string, perhaps to start off with in grade 6, and seeing that it will fit 3 times and a little tiny bit left over. And that rounding to 3 is a very important concept, rather than saying 3.14. So the fact that pi is 3 and a bit is much more useful to them. So then as they progress through, I would probably have them plotting those actual values so that you have the circumference on the vertical axis and the diameter on the horizontal. And then what we find there is we end up with the line of best fit being a straight line, and the slope of that line is actually pi. So conceptually, there's a lot of ways that the kids can sort out the meaning of pi and what it actually represents in their lifetime experience. So that's only one understanding of what pi is. There's lots of other understandings of what pi actually is, but I would like to see that as some of their first discovery, finding out, sorting out experiences. I came upon this particular
pi, the ratio of the circumference of a circle to its diameter, and this is just the beginning. It keeps on going forever without ever repeating. which means that contained within this string of decimals is every single other number. Your birth date, combination to your locker, your social security number, it's all in there somewhere. And if you convert these decimals into letters, you would have every word that ever existed in every possible combination. The first syllable you spoke as a baby, the name of your latest crush, your entire life story from beginning to end, everything we ever say or do, all of the world's infinite possibilities rest within this one simple circle. Now, what you do with that information, what it's good for, well, that would be up to you.
Okay, so you can see that's a different aspect of pi, and again, that's another learning experience that kids will come to understand that there are numbers that just don't end, okay, and they become known as the irrational. But as I said before, that's a developmental thing that can go across many grades. Another one that came to mind straight away, because the Year 9s are doing this at the moment, was Pythagoras' theorem. And I particularly love, I know that that's a lot for the eyeballs, but I did try to animate it and it wouldn't work. I particularly love that Pythagoras' theorem, one, it's a theorem, so it will last forever. Okay, and there's another little film clip on that, but I didn't bother to show that to you. And this is Pythagoras' theorem the way that I like to see it taught, with hypotenuse squared is equal to leg 1 squared plus leg 2 squared, as opposed to a squared plus b squared equals c squared, which some of you may remember. So this is Pythagoras' theorem with meaning, and I know it's a lot longer for them to write out, but it really captures what's going on with that triangle. Then if you start to replace the hypotenuse with the length of a diagonal, and then the length of the diagonal is actually the vertical leg squared plus the horizontal leg squared, and then we talk about the vertical leg being the rise, the horizontal leg being the run, then all of a sudden we have developed here a formula that the kids struggle to learn. And they struggle to learn it because it's often presented as that formula right there. Okay? And I would say don't ever just present a formula and expect the kids to learn it. Embed it in meaning. They know Pythagoras' theorem, and it's very easy for them to develop the distance formula. And they don't have to learn it by heart. They have to be able to learn the essence of it. Because whenever they see a right angle triangle, hopefully they're going to think Pythagoras. And then they'll be able to work out the distance of that oblique or diagonal. So once the students have sorted that out, they realise that it's really nothing new, but then they've learned something that they can springboard off. And then again, it springboards.
Take a square. Take A, B, A, B, A, B, A, B.
Sorry, it's a little bit loud. It's just an activity that shows the kids Pythagoras' theorem in a different way. So he's dividing the sides of a rectangle.
Now join the 4 points. I'm saying it is in the space square here. Now in the same diagram, if I push this up and bring these two together, if I push this to the right and bring this down, I'm saying it is in a square plus b square equal to c square here.
And we often call that Pythagoras' dissection, where the kids, we get them to do that in class and get them to join it together with cardboard and make that. So that's another sorting out for them to be able to do. From Pythagoras' theorem, I would say it's not very much leap from the distance formula then into the slope or gradient formula, because again, you've got the rise over the run. And again, you are moving or sorting out that information into the fact that you're working with right angle triangles here. So this is our rise, and this is our run. And once we look at the comparison of the rise over the run, we are then moving into trigonometry. So one thing leads into another, leads into another. And that's why it's really important that we embed the first experiences with the kids in real life, not simply presenting a formula and saying practice it 100 times. I'm not saying don't practice it 100 times, they still need to practice it 100 times, but at least they will have that embedding. The last thing that I would like to pick up on is indexes. And again, this is another pet learning experience that I like. I again don't like the index laws to be just taught straight off, these are the laws, this is what you do. I like it to be all brought out into expanded factor form. I have used a decimal point there instead of all the little multiplication signs. So when the kids start to discover the actual rules that are going on, if they present it out in expanded factor form, they can always come back to it. And then the rules would say that if you've got the same base and it's multiplying, you would write the base down, there's that little A again, and you would add the index powers. So that 2 and that 3 will add together to give you the 5. So once the kids are able to discover those index laws and the division, they can then start to sort out lots and lots of things. Many more laws that seem to come from nowhere, but they will be able to embed them in real life experiences if they can understand that initial introduction. Also scientific notation, or what's now being called standard form, again that has that patterning experience. So they need to be able to sort out that conceptually before they are introduced to a number of different things and asked to actually learn them. So with scientific notation, again, these are the index laws happening here, and you're asking them to present them or to fill in particular patterns, and then you can see here that you're able to develop how anything to the power of 0 is actually just 1. You can use these laws to develop their understanding about anything that has an index power. The last thing that I thought related a little bit to index power, and that's because I've been working with some of Janie's methods kids, is that if you differentiate a cubic function, you'll produce a quadratic. Now, for those of you, this is a cubic with the number 3 there, okay? And when you actually differentiate, that cubic becomes a quadratic, and then the quadratic will become linear, and then the linear will become a constant. And again, it's using the index laws. So this is higher level maths for a different reason, but you're being presented with it in a form that they need to have a conceptual understanding about what's been going on before. So it's really important to me in my teaching to make sure that you're able to embed those experiences into actual sorting out of their own experiences in order for them to take it a lot further. And I think that's it. Okay, that's brilliant.
Well, I think what Kieran, Jonthan and Amanda have captured for us, that within inquiry and the MYP, it is about the students making meaning, and that when we look at the deeper essence and the conceptual idea of what we're actually studying, it's easy to make those connections. So I could easily connect a general statement to what Amanda was talking about in maths, and I can easily use those tools in design and cross different subjects, which is so powerful. So thank you for that. I hope that gives you some tools for sorting out. We're now just going to go on to our collaborative planning classroom sessions now.